Hi, today's topic is Henry's difference between Henry's law and Raoult's law, my dears. Right, you have to understand the depth of the concept in between the Henry's law and Raoult's law. There's a very slight difference over there, right? Let us start. Difference between Henry's law and Raoult's law. Raoult's law. First, we'll define Henry's law, right? Through example. Henry's law. See, through example I will explain you, my dears. Please be focused. Right? Here I am taking one container. One container. Right? Here water is present. Water is present. Water. What, sir? This is water, sir. Water. Right. Next, see, my dears. Here, the gas molecules, that is CO2. CO2. Right? This is what? CO2 gas. CO2 gas. Now understand the concept, my dears. Please be careful, right? Here, this CO2 exerts the pressure on the surface of water. On the surface of water. It exerts the pressure on the surface of water. See, if vapor pressure is more, vapor pressure is more, or else pressure is more, right? Pressure is directly proportional to the mole fraction of gas. Mole fraction of gas in the solution is more. In the solution is more. In the solution is more. See, my dears, please be careful, right? Here, this is the gas molecules exerts the pressure on the surface of the liquid, right? Surface of the liquid. So, it exerts more pressure, the mole fraction of the gas in the water. Mole fraction of the gas is more. That's all. This is about Henry's law, my dears. So, here the CO2 is different, right? Water is different substance. Both are different substance. So according to definition, right? According to definition, here I'm writing the partial pressure of a gas in vapor phase is directly proportional to gas in the solution. Please, my dears, understand careful. Here, pressure increases, mole fraction of gas in the solution increases. Means if pressure increases, what happens? In the solution, what happens? These gas molecules increases. So gas molecules increases means mole fraction increases. See, X stands for what, sir? Mole fraction. Mole fraction. Mole fraction. So this is about Henry's law. Now, see, my dear students. Next, Raoult's law. See what it explains the Raoult's law. First, be careful, understand the depth of the concept, right? Please, my dears. Raoult's law. Raoult's law. Through example, I can explain this is also, right? Observe carefully, my dears. Here, one container is there, right? Here, A is one component there, A component, right? Next, here, B component there, B component, right? So, A is solvent, I consider, right? A is solvent, B is solute, B is solute. So, both are in one container, becomes a what, my dears? Becomes a solution, becomes a solution, becomes a solution. This is what, my dears? Becomes a solution. Now understand the concept, my dears. Right? This yes component is volatile. A component is volatile. Right? B component also volatile in nature. See, sir, what it means actually volatile? It means easily evaporated. Easily evaporated. Volatile means what, sir? Easily evaporated. Easily evaporated. See, volatile substance means easily evaporated substance. Volatile substance means easily evaporated substance. See example, petrol, right? It is very volatile substance. Why? Because if you put in jug, what happens? What do you observe? So after some time that is totally evaporated. So that is volatile substance. See, my dear students, and benzene also volatile substance, right? Some examples are there, but now we have to look at the concept. Right. This is A component, solvent. Right? B component, solute. After some time, what happens? Here, the A molecules evaporates. A component evaporates. A component evaporates. Right? Evaporates. Vapors will be formed, A component. Similarly, here also B component also will be comes out, but less it comes out. Why? Because the solute is less amount than the solvent. Right? That's all. Now observe carefully here. The pressure exerts the pressure exerts on the solution, See, my dears, the pressure exerts on the surface of the solution. See, the mole fraction of A is more, means the vapors comes out more. So that's all, my dear students. Please, humble request, listen carefully, understand the depth of the concept. Right here, observe carefully. The vapors exerts the pressure on the surface of the liquid. Right? See, if exerts more pressure means what it means actually, the mole fraction of A in the solution is more. That is a Raoult's law describes, my dear students. Please observe carefully here. The partial pressure of A proportional to XA. See, if you take out this proportionality, right, my dears? If you take this proportionality, PA is equal to P naught A into mole fraction. See, my dears, observe carefully. Here, P naught A stands for what, sir? P naught A stands for pure component A vapor pressure, right? See, the P naught A stands for what, my dears? Pure component A vapor pressure. That's all. If you see, this is about Raoult's law, my dears. Observe carefully here the definition of Raoult's law. See, observe carefully here. The vapors exert the pressure on the surface of a liquid. So, what it means actually, it means that the mole fraction of A is more. So, that is the reason vapor pressure is more. So, according to Raoult's law, what is the describes here? Observe carefully, my dears. Here, partial pressure of A is directly proportional to the mole fraction of A, right? See, this is a Raoult's law explained, my dears, right? See, if you take out this proportionality, right? If you take out proportionality, what happens? Partial pressure A equal to, right, P naught A into mole fraction of A. So, P naught A stands for what, sir? P naught A stands for pure component A pressure. See, actually P naught A is constant. P naught A is constant. P naught A constant. See, why it is constant? You think, my dears, the next lecture I will discuss, right? Here, PA is directly proportional to the mole fraction. So, this is about Raoult's law, my dears. That's all. Once again, see what is the difference between the Henry's law and Raoult's law. See, here, partial pressure of gas, right? Partial pressure of gas is directly proportional to the mole fraction of the gas. So, if you take out here proportionality, what happens? Here, P equal to one constant will come. That constant is Henry's constant into mole fraction of gas. So, see, my dears, observe carefully what is the difference, the slight difference here, over there, right? What is that difference? Here, the partial pressure of gas is directly proportional to the mole fraction of the gas, right? Partial pressure of the gas is directly proportional to the mole fraction of the gas. Here, what do you observe, my dears? Here, the Raoult's law, what said? Vapor pressure exerts the pressure on the surface of the solution. So, in the solution, mole fraction of A is more, vapor pressure is more. According to this formula, right, we'll write the definition. Raoult's law definition. See, my dears, don't mug up anything, right? Just based on the equation, you have to develop the definition, my dears. Partial pressure of partial vapor pressure of A component is directly proportional to mole fraction of A in the solution. So this is about Raoult's law, my dears. This is about Raoult's law definition, my dears. Here the very slight difference there. Here the carbon dioxide and water, the both are different, right? But here the same component in the solution, right? The solution. Be work hard, right? Take care, be focused. Take care, bye.